Hi again. This is the last part of, or the last section of the radicals chapter. So lesson 5, and it's the last lesson on this chapter. Solving radical equations. So if we have a radical equation like this equaling 4, and we want to solve it, what we need to do is basically square both sides. So we should square both sides. And if I'm squaring both sides, the square always cancels the square root because they're opposite of one another. So you'll end up with x plus 3 here, and this will be 16. And then just algebra from there. So I move the 3 to the other side, and it becomes 16 minus 3. So x equals 13. Always when you get to your final answer, you have to check to make sure it's not, or it's not an extraneous root. So checking, I'm just subbing in the 13 for the x, 13 plus 3, and I'm hoping that it equals 4. So that gives me root 16 equals 4, so 4 equals 4, check. So 13 is the right answer. Question number 2 is a bit different. So the same thing, I'm gonna square both sides. So I'm gonna put a square right here and square this and square the whole thing. So squaring the square root, it just cancels the square root, x plus 1. This, again, don't just square the x and the 1 because this expression squared, it means x plus 1 is multiplied by itself. And therefore we have x plus 1, FOIL this, x squared plus x again, plus 1. And then move everything to the other side, equate it to 0 to the right side. So you have x squared. Sorry, this is plus 2x plus 1. And I'm moving this x to this side as well, and the 1, so you change the sign. So 0 equals x squared plus 2x. Oops, let's correct that. 2x minus x is just x. And then 1 minus 1 is 0, so that's what I end up with. And then you have to factor this. So 0 equals x plus 1. Factoring this, you just have the greatest common factor here, which is x. So therefore, when it's factored like that, you know x will equal 0 and -1. That's what makes this expression 0. Again, you have to go and check. So the first check is with the answer that's 0. Checking for x equals 0. If I put 0 there, 0 plus 1, and equals 0 plus 1, that's 1, square root of 1 is 1, and that's 1, so that's check. I'm gonna check for the -1, so I'm gonna put -1 for the x plus 1, and then here I got, so again, I'm working from the root x plus 1 equals x plus 1. That's what I'm doing, my checking. And I'm subbing in -1 for plus 1. And therefore, I get 0 here, square root of 0 is 0 equals 0. So both answers work. Okay, we'll go to the next example. This next example, we have a radical on this side and a radical on this side. So I still have to do the same thing, square both sides. So When I square this side, I have to put the brackets and square the whole thing. Squaring this, basically you just get rid of the square root, which is x plus 1. Here, the square means you have to write them twice and FOIL them. So x plus 1. Now you're going to start FOILing. So root x times root x is x, as I mentioned yesterday and the day before, that when you multiply a root by itself, you just lose the root and you get x there. And then root x times plus 1 is just plus root x. And 1 times root x is plus root x again. And then 1 times 1, just 1. I'm going to move this x and this 1 to the other side, to the left side. So I have x plus 1 minus x minus 1 equals, if I add these two right here, it will give me 2 root x. This will give me 0 equals 2 root x. I'm gonna square both sides. So I'm gonna square all of this and square this. I'm just gonna take this to this side right here. 0 squared is just 0, and squaring 2 root x will just give you 4. 2 squared is 4, and root x squared, root x times root x will give you just x. Now divide both sides by 4 by 4. You get x equals 0. Check. So root 0 plus 1 equals root 0 like that plus 1. So you're checking in the original question. And that will give you square root of 1, which is 1. And that's square root of 0. 0 plus 1 is 1. So check. Therefore, this works. Let's go to the next example. This one here, the best thing to do is move this 5 to this side. And that way, you'll be able to get rid of the square root in one step. So if we keep the 5 here and we FOIL this, in the answer, we'll still end up with a square root, and then I'll have to square again. But if you move the 5 to the other side, then you won't have to do that. And that's what I advise you to do. 3x plus 10 equals 2x minus 5. When you move the 5 to the side, it becomes minus. At this stage now, you square both sides. Squaring the square root, it just cancel the square root. 3x plus 10 equals, you write this twice. Just carry the 3x plus 10 to the bottom. Now this will give you 4x squared minus 10x. Minus 10x. You could take your time foiling this. I'm just going a little bit quick with it. And now you move everything to one side, equated to 0. So you have 0 equals 4x squared minus 20x. And moving the 3 to the other side will be minus 3x, so that's minus 23x. You could take your time doing that. Plus 15. Now, we have to factor this. For some of you who didn't factor before, a trinomial with a leading coefficient that you cannot take out as the greatest common factor. I have a different way of doing this. So I look for what multiplies to give me 60. 4 times 15, give me 60. So what multiplies to give me 60 and adds to give me that middle number, which is negative 23. I'm just gonna take this to the other side. So 0 equals, I'm gonna factor this. The two numbers that will multiply to 60 and add to give me negative 23 is negative 20 and negative 3. They multiply to give me positive 60 and they add to give me negative 3. So that's what I'm gonna write here. The only thing, it doesn't stop here. That would be too easy. because we have a 4 right in the front there, so those two numbers right here, I have to divide them by that 4. So this leading coefficient, once I do this as a shortcut, then I just divide this and this by 4. So 0 equals x minus 5, because 20 divides by 4 and give me 5. This doesn't divide. So what you need to do, just push the 4 in front of the x there. So 4x minus 3, and that is your factors. Or these are your factors. You could use decomposition if you like. This is a lot faster for me. And if you learn it, it's a lot faster. It'll save you time on during writing tests. So therefore, x equals 5 and 3/4 is our answer. But we still have to go and check. So I'm going to check the 5. Check x equals 5. So I'm just going to go 3 times 5 plus 10 plus 5, sorry, right here. I'm checking in the original equation, of course, equals 2 times 5. So that's 15, sorry, plus 10 is 25. So square root of 25 plus 5 equals 10. That's 5 plus 5 equals 10. 10 equals 10. Check, so this one works. And how about the 3/4? And I know a lot of you don't like fractions, but I'm going to show you how to check x equals 3/4. So now this is going to be a little bit ugly. So 3 times 3/4 plus 10 plus 5 should equal 2 times 3/4. At least we know the right side here is going to be 3/2. Since the 2 cancels, reduces to give me 1, and 4 gives me 2. Here I'll get 3 times 3/4, just 9/4 plus 10 under the square root plus 5 should equal 3/4. I'm just going to take this right here because I don't have room. Sorry about the mess. So I'm going to do common denominator, which is 4. And I'm going to have a 9 there. And then the 4 multiplies by 10 gives me 40. So that's 40 plus 5, which gives me 49 over 4 plus 5. And 49 over 4, sorry, that's square rooted, will be 7/2 plus 5. That's 10 over 2 plus 7 over 2 is 17 over 2. So it does not equal 3/2. And therefore, this is not an answer. 3/4 is an extraneous root. And the answer is just 5. One more question. So one more question and the last question. This one here, I would advise you to move this to the other side. That will look a little bit easier and less messy. So I'm going to go 2x minus 1 equals 3 minus, moving that to the other side will change the sign to minus x plus 3. Now at this stage, I'm going to square both sides. And this will give me 2x minus 1 equals, and this, you'll just have to write it twice and stop foiling it. Um, 2x minus 1 equals 9. 3 times 3 is 9. 3 times negative x plus 3 under the root will give you minus 3 brackets, root, sorry, x plus 3. And then you'll get the same thing by multiplying this into here. So minus 3 root x plus 3. And then negative times negative is positive, and when you multiply a root by itself, you just lose the root and you get x plus 3. Now at this stage, move everything to this side except for the root, the terms that have the root in them. So I'll have 2x minus 1 minus 9 minus x minus 3 equal, and these are like terms, so I could add them and they give me negative 6 root x plus 3. Now 2x minus x is x, negative 10 minus 13 equals negative 6 root x plus 3. I just want to make sure I didn't make any mistakes here. I don't like this. This is going to give you a lot of fractions. 2x, 3, 9. That's negative 3 there, negative 3 there, that. And then that's just x plus 3. So that's 12. The other side is negative 13. Okay. Now we're going to square both sides again. So square this and square this, because we still have to get rid of the square root that we are left with. So this will be x minus 13, writing it twice, equals the square of squaring negative 6 will give you positive 36, and the square of this will just be x plus 3. I'm going to take this here and I'm going to start foiling. So x squared minus 13x minus 13x plus 169 equal 36x plus, I'm tired, I'm going to use my calculator. 36 times 3, 108, that's what I thought. Now I'm going to move everything to this side. So x squared, this is minus 26x minus 36x. Oh gosh. Negative 26 minus 36 equals negative 62. And then 169 minus 108 equals 61. So plus 61 equals 0. Actually, this one works to be a bit easier than what I thought. Open two set of brackets. 0, so the two numbers that multiply to give me positive 61 and add to give me negative 62. If you're thinking about this for too long, you shouldn't, because 61, the multiples that multiply to give me 61 is 61 and 1. And if you make them both positive, negative 61 and minus 1, they multiply to give you 61 and add to give you 62. So therefore, x equals 61 and 1. Now check. Or maybe just let's do the check in a different color. Check. I'm going to check x equals 1 first. I'm going to go back to the original equation. I have 2 times 1 minus 1 plus 1 plus 3. Does that equal 3? So 2 times 1 is 2 minus 1 is 1. Square root of 1 is 1. Plus that's 4. Square root of 4 is 2. Equals 3. 3 equals 3, definitely. So this is a check. This is check. How about the 61? X equals 61. We're going to check that, and we have 2 times 61 minus 1 plus 61 plus 3 equals 3. 2 times 61 is 122 minus 1 is 121. Square root of 121 is 11. Plus that's 64. Square root of 64 is 8. Equals 3. 11 does not equal 3. So this here is an extraneous root. So the 61 is extraneous. Root. this is it. This chapter is over. Radicals is done. So I hope this will help the grade 11 students this year. Till next time, we'll be going to chapter 2. See you then, and stay safe. Bye-bye.